Good evening to one and all. So today we are going to see Clausius-Claperyon equation, one of the important equations which describes phase change process in thermodynamics. So it is a relationship between saturation pressure, temperature, and enthalpy of evaporation and specific volume of two phases involved. So phases in which means liquid, vapor, like that. So this equation provides a basis of calculation of properties in a two-phase region, or you can compare properties between two different conditions. So imagine you are trekking with your friends and you decide to make a cup of tea using a portable stove. So as you climb to higher altitude, you notice that the water boils at different temperature than it does at sea level. So to understand this change in boiling point, we will see what Clausius-Claperyon equation is all about. So this is the equation which we are going to derive. So logarithm of P2 by P1 equal to HFG is nothing but latent heat of water. That is the heat which is required to phase change from water to steam, divided by R, that is gas constant, into reciprocal of temperatures, that is 1 by T1 and 1 by T2. So here pressure 1 and pressure 2 can be taken as pressures at two different altitudes, and temperature 1 and temperature 2 can be taken as temperature at two different altitudes. So you're going for a trek and you are boiling the water at two different altitudes along your route. So we are going to derive this Clausius-Claperyon equation using one of the Maxwell's relations which we derived earlier. So the equation which talks about rate of change of pressure and temperature we have to take. So this is the Maxwell relation we are going to take. So dou P by dou T at constant volume, that is rate of change of pressure with respect to temperature at constant volume, is equal to rate of change of entropy with respect to volume at constant temperature. So this is the relation which we are going to take. And so we are talking about phase change. So we all know that the suffix G denotes steam and suffix F denotes water. So the rate of change of pressure with respect to temperature is equal to rate of change of entropy with respect to volume. So rate of change of entropy is Sg minus Sf, that is entropy of steam minus entropy of water. That is the latent entropy of the steam. Similarly, specific volume of steam, dry steam, minus specific volume of water. So that is latent specific volume. So S of G divided by, so dP by dt will be equal to S of G by Vfg. S of G is nothing but entropy required for phase change, and Vfg is volume change required for phase change. So entropy is nothing but enthalpy by temperature. So we are replacing this S of G by with H of G by temperature. So now dP by dt equal to HFG by T into Vg. So P by Vt, we are equating this Vt with RT square. So P by RT square. So this T into V is replaced with RT square. That is P by RT. HFG into P by RT. So now while rearranging, we are getting that HFG equal to RT square by P into dP by dt. So now we again rearrange so that we have to integrate. So this T square and T will get cancelled, and dP by B, that is the pressure terms in one side and temperature terms and constant in another side. So we are getting that dP by P equal to HFG by R into dt by T square. So now we are integrating this dP by P terms from with respect to P1 to P2. Similarly, HFG by R is constant, so that it is taken out of the integration dt by T square. So while integrating dP by P, we will get ln P, and when we substitute the limits, we are getting ln P2 by P1. Similarly, when integrating dt by T square, we will get that is T power minus 2 into dt. We will get T power minus 2 plus 1 by T power minus 2 plus 1. That is T power minus 1 by minus 1. So we will get 1 by T1 minus 1 by T2. So ln P2 by P1 equal to HFG by R into 1 by T1 minus 1 by T2. So this is the final equation. That is logarithm of ratio of pressure will be equal to hfg by r into 1 by T1 minus 1 by T2. So if you know the atmospheric pressure at two different altitudes and one of the boiling points, you can find a boiling point at another altitude, or if you know boiling point at both the altitudes and pressure at one point, you can find pressure at the higher altitude. So that this Clausius-Claperyon equation can be used to find pressure and boiling points of fluids at different conditions. Thank you.